So we've developed AI models, we've performed stress tests and local validation, and we're itching to use them. So what's so difficult about deploying the models in practice? Just sign the contract, connect the systems, and we're ready, right? Though a topic of immense interest, now aligning with goals across the enterprise for increasing availability of AI in practice. Deploying AI is not trivial. This is an extremely intentional process with significant prospective planning for frameworks to sustain and scale its use, to ensure ongoing monitoring, and maintain an ability to adapt to challenges and demands in real time. As we think about AI deployment, we may ask, what resources does it take to deploy and maintain an AI solution? How do we scale multiple solutions across an enterprise? And what can we do to adapt to changing paradigms and increasing interests for adopting the latest trends in a rapidly evolving field? Thinking about resources, we often ask about balancing between clinical and operational duties. And it sounds like our guest may have just found that sweet spot. I'm your host, Ali Tejani. This conversation is part of a special AI video series presented by the AJR, where we host multidisciplinary conversations about some of the most pressing topics surrounding AI in medicine with thought leaders in the field. I'm joined today by Dr. Kevin Groot Lipman, Clinical AI Implementation Lead at the Netherlands Cancer Institute. Dr. Groot Lipman, is it okay if we continued our conversation on a first name basis, just to help with flow?
Of course, we love that.
And so thanks again for joining us. It's just so exciting to have an opportunity to hear more about the work that you've been doing at the front lines, really pushing this frontier. You're quite a versatile individual, Kevin. I remember one of our first conversations about a year ago, and I was intrigued by your unique responsibilities at the intersection of clinical medicine and AI. Can you tell us more about your role as a technical physician? I think this is a term that some of us may be familiar with, but it may not be what most of us are used to thinking about in this space.
Yes. Well, first of all, thanks for having me and this invitation. I'm looking forward to this conversation with you and have been admiring your work on clinical AI implementation and your papers for a while. So the pleasure is all mine. The technical physician is actually quite a Dutch specialty. I think the study is only here at the universities in the Netherlands, and it's aiming to bridge basically the engineering disciplines with the medical disciplines. And so part of the courses you get are medicine, part are engineering, coding, and that way they aim to jump into this technological gap that's entering the clinical domain. So you can think of where technical physicians, once they graduate, where they shine. It's things like 3D modeling, 3D printing, surgical navigation, nowadays theranostics, and of course AI implementation.
And it's great to hear that there's a dedicated time and space for that role. Uh, do you see this role translating to other countries then, or other contexts?
I think so. I'm getting reached out more and more about universities that want to talk to me about this profession and whether they could host it. What we see is you need some daredevils. And I think in Boston, they actually tried it already 5 to 10 years ago. But here it takes like 2,000 euros a year to study a course, and also a new course where, as a student, you take a gamble because you don't know what profession you're end up in. If you do that in Boston, I think 50,000 a year is not an unreasonable number to pay. So that's quite a gamble, right? So getting students there excited for a study for a course that you don't know where you end up in, it's a bit tricky. So we see it more now in the European countries where you just have to pay less, and if it's not for you, you can easily go to another course or can transform your profession once you graduate.
And is it fair that to say that you have dedicated time in that profession then, where you have a set boundary of these are my clinical duties and this is how much time I have allocated to that, and then here are the more operational duties and this is how much time I have allocated to that role?
Yes, it is. And I should notice that the technical physician is on a much wider spectrum, so to say, from medical to technical than, for example, physicians, which have a lot of clinical duties, of course. And then if you do anything outside of medicine, you're kind of the exception. We've also a lot of technical physicians going, for example, into industry or research, but most of them end up in the hospital where they do clinical duties with operational responsibilities.
So, speaking of recent real world implementations, your work examines clinical deployment of AI, particularly examining real world implementation of thoracic imaging use cases. And if I'm not mistaken, specifically examining pleural mesothelioma volume changes over time, whether it's disease progression or response to therapy. I'd love to hear more about that experience. What was it like deploying these solutions, this platform in real time with data visualization, incorporating user feedback, and just thinking about the complex integrations under the hood that needed to be in place for a seamless, streamlined experience?
Yes, exactly. It's been a very rewarding experience. It also took a lot of work, of course, plus clinical AI implementation, especially adoption by oncologists and radiologists. It's in the details, and exactly like you're mentioning, in the seamless experience that they have. And maybe one step back, I think in 2020, 2021, while I was still doing my PhD, we were in this meeting with a few radiologists, oncologists, and there's been a tremendous amount of AI research being published, but hardly anything translates to real clinical impact, right? So we were thinking, all right, a lot of problems in AI research is, well, we have this data set, whether it's public or private, and let's try this AI method on it and then publish about it. We try to turn it around. What are the real clinical problems here that we can solve? And where does AI naturally fit in this problem? And one of these target areas was response evaluation. So, on multiple CT scans, can we follow tumor growth? Currently, this has been done and still is being done by RECIST, so the response evaluation criteria in solid tumors, which measures these diameters. But literature has been showing that it's very much dependent on inter-observer variability and also on your target lesion selection, right? So then the question is, why can't we measure the total tumor volume? We've this amazing technology of CT scans where we can visualize the body in 3D, and then we decide to somewhere in this tumor draw a diameter and measure at that spot. And that's mostly feasibility, right? So it takes, I think, radiologists now 3 hours for pleural mesothelioma to annotate every pixel that is tumor containing. Um, and that's already barely feasible in research, let alone in clinical practice. So somewhere along the way, we decided to measure diameters instead as a surrogate of this total tumor volume. And this has been the standard for so long that everybody is thinking about that. And even while we developed AI segmentation models that can measure the total tumor volume, I generally get the response, oh, that's amazing. Now we can automate RECIST diameters over time. So, I mean, so baked in. And what we're saying is, well, let's not do it. Let's rethink this and just track the volume over time and also come up with new criteria that radiologists and oncologists can use to work with these AI volumes. And we see that that works amazingly well. We see huge adoption by our oncologists. They love it. And most importantly, our patients actually love it because it removes some of the anxiety they had with the diameter based methods, where the oncologists say, well, could be growing. This part is growing. This part in the CT scan, I see the tumor shrinking. I'm not sure. Let's continue for another cycle, and then we'll make a new CT scan in 6 weeks, and then I know more. And what patients have been telling me is that that's actually the worst, right? Diagnosis of cancer is devastating. Sometimes you are willing to have these very toxic side effects if you know the treatment is working. But coming back to that anticipated moment where the doctor is telling you whether you respond and hearing, actually, I don't know, it's anxiety inducing. And that's something we can now solve with this AI volumes that very accurately measure the total tumor volume in the CT scans. And it gives the confidence to the oncologist to communicate with the patient whether they are responding. And the oncologists are now basically using it for all patients with pleural mesothelioma in our institute. And we actually getting patients from other hospitals that are asking for a transfer here because they want to be followed up with this AI technology. So I think that's the biggest compliment we could have gotten.
I'm hearing a lot of different themes here, and I think we have time to dive into each one of them. So one thing we'll table for a bit later in our conversation is the next steps from your role and your perspective as the clinical AI implementation lead. So we'll put a bookmark there. But what I'm hearing is a couple of things. You and your team identified a significant problem for radiologists from a physical, a mental cognitive burden. You identified a potential solution and aligned it with what seems to be a more optimal way of assessing or evaluating the pathology. And you have transparency with your patients about the use of this technology and how it's assisting physicians in diagnosing or assessing uh, their condition. Are those fair themes
Correct.
so far?
Yeah.
I think all of that is very exciting, and so I want to hear really quickly. Then, as someone who is on the technical side, right, as a technical physician, as the AI implementation lead, before we get into the other very interesting topics here, where are those AI results integrated? Right? Is this information that the model then pushes over to your EHR? Is it a separate viewer? Is it something completely different? Where are the end users seeing those ultimate AI results?
Yeah, that's a very interesting topic. We have been trying to integrate this with our PACS and our EHR and deploy the AI there locally. But the PACS and our EHR, they are not friends. So to speak, we went into a bit of marriage counseling with them, but we couldn't really make it work. So we started a completely new IT infrastructure in our private cloud. We call it a data lakehouse. And what we're doing every night at midnight, we're copying our EHR there and updating it as a copy. And from PACS, every medical scan that's being made is also automatically being forwarded from our PACS to what we call our cloud PACS. And in this data lakehouse, we are breaking the traditional silos. We have all the patient information in one integrated environment, and this is actually super powerful. So what we're now doing to deploy this is the CT scans are being sent to our data lakehouse. And for every single CT scan, we check the patient ID and the diagnosis and the pathology report. That's all there in one place. If it mentions pleural mesothelioma, or if the indication of the oncologist mentions pleural mesothelioma, then we forward that CT scan to our AI inference platform. We run inference, so the tumor is automatically being delineated and we have a volume. Actually, 15 minutes after the patient was in a CT scan, we have a volume available in our EHR for the oncologist to see. I'm saying EHR because that's where it's displayed. It's integrated there, and they can just select on the left side in their EHR the tab AI volumes. But what they're actually seeing is a web browser running on this data lakehouse in the cloud. Given that we have single sign-on, so you authenticate with your hospital ID and your password, so you don't have to log in separately, it does it automatically for you. It feels like a seamless experience in your EHR, while it's actually on the background running in the data lakehouse, where also all the AI volumes are residing. And that's one super powerful technology for our oncologists. So for them, it feels seamless. For us, we can handle everything in the background in our data lakehouse, and we also have all the information there where we have full access.
This almost sounds like a Wizard of Oz experience where you have all this complex infrastructure working in the background that the user may not realize, right? And you see this kind of seamless, really awe-inspiring end product. And so this is really interesting to hear. And not to get overtly technical, but granted, it doesn't seem common to have this much seamless integration and scaling it really, right? And so, what was the experience like to make sure that all the systems were interconnected, that they were able to communicate with each other, right? What we often refer to in technical terms as interoperability. How is that achieved here? Because it sounds so seamless from what you're describing.
It was a huge undertaking. And to be frank, we couldn't have done this alone. We did this in a public private partnership, what we call digital oncology. So that's a partnership between our hospital, the Netherlands Cancer Institute, and Kaigo AI, this company that has all these engineers that could build this cloud infrastructure. And then they deploy it on our private cloud. We give feedback and customizations, and then they update it. So it's a seamless experience for us. You need this engineering talent from the industry, from the private sector. There's just no way a hospital can build this on our on themselves. The clinical feedback that we gave from the hospital and where they had to move was super powerful for them. In this uh, public-private collaboration, we built this together, and hopefully it will later also be available for other hospitals via our private partner.
And so it sounds like you're planning to scale this quite a bit.
Yes, and it's good, I think, to disentangle there the AI part from the IT part. And I think the IT part for sure can only be scaled through private partners where hospitals can actually buy a data lakehouse from themselves. They can connect their PACS and their EHR, and that facilitates a lot of AI deployment, but also analytics that they can run for their hospital themselves in this cloud environment. From the AI part, that's a little bit more tricky because you have regulatory constraints, right? You need to go through MDR certification, or in the States, to the FDA before you can really scale. And what we're currently using in our regulatory strategy is the in house exception in the MDR, which basically means that if you develop something in house, then you have an exemption from going through the notified body. You still have to do all the documentation, it's all equal, but your own medical physicist can basically sign off. And the constraint is you can only use it on the patient population in your hospital, so you cannot yet scale it. But this is very powerful, so we can get real life feedback from our oncologist and radiologist in the deployment. Our turnaround time of this regulatory documents for the first solution was a year and a half when we still had to figure it out and had to get a lot of advice. For the newer AI solutions, we're bringing that down to around half a year before we get a sign off. And once we are very confident that this is a product that the radiologist wants to see, the oncologist wants to see, and most importantly, the patient benefits from, then we can go to the notified body, to the FDA to get this real check mark, and then we go on the commercial market and scale it. And most likely we'll do that with private partners and not via our hospital ourselves.
Following that conversation on regulatory considerations, would be okay to talk a bit more about that process. It sounds like, again, simultaneously you have multiple things going on, right? You have the not just the model development and the fine tuning and monitoring, but getting the feedback from the clinical stakeholders, uh, thinking about what happens downstream with this information, but also now another piece of the puzzle, which is that regulatory component. And so did you and your team internally work with the regulatory bodies, or did you again have a maybe a third party consultant, or what was that process like of navigating with different regulatory agencies, especially as you start to think about, well, each country or jurisdiction may have its own agency to work with as well.
Yeah, correct. So we didn't really work with the regulatory agencies because we didn't have to go to the notified body, but we worked with third-party advisors and consultants to lead us the way. We have a lot of in-house expertise actually on this in-house MDR on the hardware side, where the medical device regulation is also into play, but not specifically on software and AI. So that's where we really needed feedback and advice from the outside world. We worked together with several private partners there to advise us on where we had to tune our documentation and improve. And that makes it confident that we covered everything. But it was a lot of work. You have to think about much more than just developing a good AI. And this whole implementation process, maybe to put it in perspective, and maybe rephrase what should I stop? This whole implementation process and regulatory process took more than actually the AI development side, right? So it's super complex, but once you went through it and you have your backbone set up, then the next projects are quite doable. And to give you an example, following the AI Act in Europe, we need to do an DPA Freya, as we call it, Data Protection Impact Assessment and Fundamental Rights Impact Assessment. And we wrote it in such a way that we did it for all the segmentation models as an overarching framework of this regulatory document where every new segmentation model that we develop can basically inherit the common theme from. And then you just have to do the extra things very specific to that segmentation model, but you don't have to rewrite all this documentation. And that makes this also, I think, our regulatory strategy very scalable for this in house procedure.
And you're essentially establishing a blueprint for the next project or the next solution.
Exactly. So now, once we start new projects, also research projects where we think, this might end up as a segmentation model in the clinics, we can already take these steps into account during the development cycle. And that makes it much easier to have these regulatory constraints well defined.
And I think that's a really admirable model that I'm hoping that our audience can take away here and implement in their own practices. And just really quickly before we move on to our next topic, then, I love this idea of an AI solution enabling us to gather insight that was previously unavailable because the task itself was too cumbersome and we simply weren't able to perform it. And so we left these, maybe not doors closed, but maybe they just weren't as easily accessible, right? To let us know how a disease is progressing, how treatment response is evolving, if there's other information, other data that we may not be leveraging for patient care. But now that we have this AI solution that makes it easier to perform a certain task, we may have new information to work with that changes the way we see a disease process or management. And so, in your experiences, has that data from the pleural mesothelioma pipeline been used to guide practice recommendations? Have there been any changes to that standard of care or that reference standard that was there previously?
It has been actually, yeah. And our oncologists are now mainly using the AR tumor volumes. That, of course, they have to check them themselves or the radiologist and accept it, because there always has to be a human in the loop. And that's still quite a vague term. But the way we use it is that there is an AI segmentation. You always have to inspect it in our DICOM viewer, which is also integrated in our EHR, and then accept and reject it. And I think what sets this apart from other of AI results is that in segmentation, you can really see the pixels that are annotated, right? So it's very hard to do, but super easy to verify because you can just scroll through it and say, well, yes, this sounds about right, and then accept it, and you take accountability for this final tumor volume in milliliters that's then being used for clinical decision making. And because it's so easy to verify, oncologists love it and are also willing to take this accountability. Well, if there was an AI model very similar, just taking two CT scans and saying as a black box, well, this is progressive disease, patients has to stop treatment, I cannot really check it. I don't know where the parts were in the CT scan that the model based its decision on. And then it's very hard to take accountability for that verdict. So I think this seamless integration that we have, plus the easy verifiable results that we show, makes it a very good experience from our oncologists and radiologists to adapt.
So the trust in the AI is coming from being able to actually see what it's measuring, what it's looking at, and then deciding on your own as the final decision maker that this was accurate or this was not accurate.
Correct? Yes. And at the same time, it also sometimes yields extra cognitive load that we have to think about, right? And where prior to our AI volumes, maybe radiologists would have just reported invasion of the thoracic wall. And now they really have to think, all right, is the line that the AI drew around this invasion, is that actually correct or not? And maybe is it even clinically relevant to adjust that to the right line if it's just somewhat off, but it won't really impact the total tumor volume. So we're opening a new uh, possibility basically to research the impact of certain decisions and what's clinically relevant and what's not. And we see that more and more now with our medical professionals that are getting more accustomed to these AI results, that they're making mental models, right? Maybe the AI was a bit off there. I accept this result, but in my clinical decision making, I'm taking this into account. And it's very fun to see how this adoption is leading to new conversations, new discussions with our medical professionals.
I think that's just so exciting that we're able to, again, have these new discussions that are maybe previously we weren't able to devote time to or didn't even know to have, right? And one quick note is that it sounds like there's no free lunch, right? With these added capabilities, there's always some maybe additional cognitive load or some additional task, but it sounds like the consensus is that the pros of using this solution, of the potential, whether perceived or verified, impact on patient care outweigh the added work that may come with this technology. Is that fair?
From my perspective, very fair to say. Of course, I'm biased because I'm very optimistic about this technology. But I think if we see our radiologists, our oncologists, and our patients and how happy they are with the technology, then that's a fair assessment.
So, Kevin, we've talked about a few different ways to look at the data. We've talked about segmentations, as you mentioned here. We've also discussed something a bit more binary, where it's a yes or a no, a present or an absent. Or maybe we have a brief representation of more complex AI results where it's a summary statement. The AI solution determined that there was X% of change over time. That represents disease progression or treatment response. What we see, though, is that there are a multitude of ways that we can present aggregate results. And we now have business intelligence solutions that can help us slice and dice the data in quite a few ways to help us have this actionable insight for next steps. So I think we have to ask if there is a similar process of data visualization for all use cases, or is there a more effective way that you and your team have found that's the default that then you can fine tune based on user preference or the needs that your team may have to then have the information to make that next step? What does that process of determining appropriate data visualization look like?
I think for segmentation models, if we scope it on tumor segmentation, for example, we visualize it in multiple ways. That can be with only outline, or also that you see the inside to really catch the eye, right? Which is more important for the smaller regions where you want to attract attention to. For the larger tumors, we prefer to only show the outline so you can see what's inside the tumor and whether the AI actually made a correct decision boundary there. Especially with in the thoracic part, sometimes you have atelectasis that's adjacent to the tumor. You want to make sure that it didn't include that part. We also have a new deployment that we're working on now, the brain metastasis, where it's very important that you can click on every lesion and it brings you in the viewer automatically to that lesion to see if that's actually correct. Because of the clinical consequences of having brain metastasis, we only send it first to the radiologist before the rest of the house, basically, so to say, can actually use that result. And then we use a different strategy that on a lesion basis you have accept reject. And once it's accepted, only the accepted lesions are being visualized to the rest of the medical professionals.
Do you think that's a paradigm that should be in place regardless of the use case, to where the imaging expert, the imaging professional reviews the AI results and then confirms the ones that are actually true and before sending it over to the rest of the clinical teams? Or is that an added task again that could limit growth of an AI solution and maybe even delay any downstream action, right, on positive findings? That may be true.
I think it really depends on the use case and also about on the team play between your oncologist or treating physicians in general and your radiologist. So, for example, if you want, as a hospital, to do kind of a 1 day shop where the patient goes in the morning into the CT scan and shortly afterwards to their consultation with the treating physician, I think you should immediately send the AI or make it visible to the treating physician, this AI result, because then they can use it in a consultation. And at this short time period, if your radiologist doesn't have a time to check, I think it should be immediately available. And then if the radiologist afterwards in their report is checking it and is not agreeing with this AI result, we have to call the patient back. And I think it depends on the prevalence, also on how often the AI is right, but that's for the mesothelioma now the correct strategy. Because otherwise you cannot immediately use your AI volume result in the consultation, which actually makes it so powerful. Now, for certain topics like brain metastasis, I think for sure it has to go first to the radiologist. They have to approve it because of the clinical consequences and the very much the domain expertise that you need in MRI brain to being able to distinguish the false positives from the true positives with these AI models. And what can be a drawback is that if the AI performs very well, it's sometimes very plausible, right? If you put an outline around a certain structure, it already seems like a lesion, even if it may be a small vessel. So it's an exciting field. I think that the community, the radiologists and the training physicians and some of the technical experts that can basically decide these workflows have to come together and decide on a per use case basis what's the right strategy.
And so, talking about exciting spaces, let's turn up the heat a bit more here and talk about a really hot topic right now, foundation models. And so, a similar conversation I think that we've had in terms of the considerations, but we're seeing quite a bit of accelerated interest in trying to get this translated from R&D, or right research, to that bedside, that clinical practice. And we've had a bit of discussion in various forums, videos like this, podcasts, papers, reviews from some really major outlets, right, about the inevitable impact of foundation models, not just on radiology, but I think on all of medicine, similar to other sectors. We're seeing startups and academic research groups shift momentum towards generalist models over the last few months as well. I think we'll continue to see this at upcoming conferences, and this may be a theme that emerges. It's almost a race to that first generalist model that can perform all of these tasks, and it can automate creation of the radiology report, right? It can really maximize the efficiency in your workflow that then you can translate to some sort of dollar value, some sort of return on investment that's either direct or indirect. But as a clinician and as the clinical AI implementation lead, is this the right direction in terms of our investment of time and resources? I guess this may be a loaded question, but when I think about this, maybe there are other problems that still need to be solved before we take a look at where this fits in to our current workflow, our current context. But on the flip side, on the other hand, do we want to miss out on this really exciting wave of new technology and the potential benefits that it may unlock?
I think we first have to define also for the listeners what we mean when we talk about foundation models. And I think the general audience, when they hear foundation models, they think about ChatGPT, right? In text, and that you can chat with some chatbot and get a response. I'm very bullish and optimistic about foundation models, but not so much on that part. So we can also bring foundation models to the image space. So how ChatGPT is trained, you download the internet, you predict the next token or the next word on the internet scale, throw a lot of computer at it, and then you have your foundation model. From there, you can do some fine tuning that it can answer your questions. What I think will be happening and where we have to go is these foundation models for MRIs and for CT scans, where we train on the images, which is much harder because we cannot really predict the next words. We have to come up with strategies, but make these foundation model understand the underlying data structure of the human body visualized by CT scans. If we can do that, that opens a whole range of possibilities that we can deploy. And we can think of maybe a new step, right? So what we're doing, we're in CT scans, we're shooting radiation through the human body, having detectors on the other side, and we do a 360 flip around it. And we create a sinogram that we then reconstruct in a CT image. That CT image, I think, is going to be encoded by these kind of foundation models to extract the relevant features that then new AI models on top of that can use. That could be LLMs to draft a radiology report, but I think it's way more relevant to do scalable solution in the image recognition space. So, for example, not only segmenting pleural mesothelioma, but now detecting all types of cancers, all kinds of metastases. Because our limitation of the current AI segmentation model is still that it does one tumor type, right? It doesn't do the metastasis, it doesn't do the lymph node involvement. So with these foundation models, if we can pre-train them on, let's say, millions of CT scans, we can create a foundation model that understands this data, and then we need way less labels to train these segmentation models on top of those. I think that's the direction we have to go. Now, what you have been seeing, I think, in the first papers here, is that people are trying to train 2D foundation models. And that makes sense if you look at the radiologists, they scroll through these 2D slices in this 3D volume, but that's only because our human brains can only visualize and process this information, right? It's very hard for us to check a CT scan in 3D. These algorithms can. So I think we definitely have to invest in 3D foundation models, understand the structure in 3D, and even better, if you're in the temporal domain, so longitudinal tracking patients, we should go to 4D and then use foundation models to see the disease evolution over time and learn from that. And that's, I think, where we can get superhuman performance. Because what you see also with radiologists, and they basically compare two CT scans at a time, but not the prior 10 or 20. And then sometimes it happens when you see two CT scans, you think no change, and you compare it with the prior one, no change. But overall, this changes stacks up. And I think there, if we can retrieve those kinds of features via these foundation models, that would transform the way we practice medicine here.
4D foundation models. I think we're looking at coining a few exciting new terms here as well. And I think that's really exciting to think about. I don't know if it'd be a progressive step there to that has to be, sequential, but maybe even looking at that now, right? That while we're developing these 2D foundation models, why not explore the potential for longitudinal tracking? So I think that's really exciting. Uh, my question, I guess, then is how many use cases can a foundation model be expected to support? It seems like at some point you could just continue adding more subspecialty, more anatomies, modalities, right? At what point is it too much in that all of a sudden you're having to review all of these potential findings, right? And are they real? Are they not real? How do you manage them? And then do you trust the model for all of them or maybe just for a subset? I, th- I think as putting that clinician hat on, I would love to see some sort of very specific guardrails in place before we deploy those tools, right? But is that a fair way to think about this?
I'm not sure. I would maybe rephrase it because I think for me, that question is similar to how much use cases can CT imaging support? And that's very hard to answer, right? Anything humans can come up with can potentially be supported. Whether it's clinically relevant, probably a lot of them aren't. But I think we should view these foundation models more as an accurate summary of the CT scans that's a machine readable format. And then you can build new AI models that are much smaller to train and easier to train on top of the features that are extracted by the foundation models. And if we look, for example, at the current state of radiomics, where normally you segment a structure and you get hard-coded feature out of it via some mathematical formula, this doesn't seem to generalize well and scale to clinics. And I think the reason is that because it's hard-coded, we cannot distinguish the noise of scanner patterns or scanner variability from the underlying biology that is a signal in the CT scan, right? And this is all condensed in one feature. And if you now deploy your radiomics model in the next scanner of hospital, it doesn't generalize, it fails. Now, I think what these foundation models are doing well is they learn these features. So they are able to distinguish this scanner noise from the underlying biology and put them in separate parts of this feature vector. So I think with this new paradigm, and maybe we can call it these foundation models, these embeddings that we're getting out of it, Radiomics V2. I'm not sure what the community will come up with, but then I think we will make much progress in the way we do radiomics. And then we have a chance actually to build new AI models on top of these features that can lead to some clinically relevant downstream tasks. The fact that we can do all those things, fully agree with you, shouldn't mean that we actually have to deploy those in clinics, right? Because we can do whole body segmentation and having all the muscle volume, fat volume, opportunistic findings. What's clinically relevant? That's an all new research area separately that we have to investigate. I think under the hood, we should measure certain things. For example, if we want to track lymph node involvement, you have to segment all lymph nodes. I don't think we should show them to the clinicians and the radiologists. I think we should only show them if we find really urgent finding. For example, one of these lymph nodes is growing massively over time. That should be flagged. So we have to be very selective with the AI findings that we have and the which ones we actually show to our clinicians as urgent to prevent this cognitive overload.
And it seems like one of the easiest ways, as you alluded to, would be to show the positive, the really actionable findings, as opposed to what seems like a long list of potentially normal or negative results to avoid that cognitive burden.
And I think this is also very cultural, right? So different cultures put value in different trade-offs between these false positives and false negatives. And I think we should draw or get some learnings out of the screening literature where you have exactly this same problem, right? You can detect all cancers in screenings, but that means that 8 out of 10 people that actually have nothing, you induce anxiety by sending them a letter that you may have found something. And it's very cultural to see where is that trade-off? How many cancers do we want to detect versus how many people do we want to induce anxiety? Well, there was actually nothing. And I think with everything we will be able to measure with AI in the coming decade in a diagnostic center, we get very similar discussions.
Just to bring back a link that we weren't able to explore in detail from earlier in our conversation, I could imagine patients as they find out more about foundation models or similar tools that we've been describing the last few minutes here. Maybe a question comes up of, well, how many other patients had the same finding flagged on their study, and what does that mean? I guess this is my way of trying to bring back that conversation of what is the scope of the discussion that we should have with our patients, right? About the use of AI once it's fully deployed. And I think I'd love to hear this informed by your experiences in real life, right? With that pleural mesothelioma volume monitoring tool and how patients viewed it. And again, how that could translate potentially to these other frontiers.
Yes, and I see a huge change there also in the patient community. When I talked in the patient communities like 3, 4 years ago, nobody really knew what AI was, and frankly, it was quite scary, and I completely get that. And actually, last week I was at a conversation with patients, and I was actually surprised. They were, if doctors think AI is the best way to go forward and help them with the analysis, we trust that. You should use it. And even there was unanimous that they actually, in this patient group, they didn't even want to or need to know AI was being used. They put their trust in the doctors, and if the doctors and the medical community thinks AI is a very good assistant in the way you practice medicine, I want it. I just want the best care. And that's a completely mindset change that I saw 3, 4 years ago with patients. They love the technology on the volumes also because they can, so interpretable, right? So they can see their own tumor volume growing or shrinking over time. And that's, yeah, really helps them with their state of mind as well. Now, where we will be going, I think, is we let all clinical data, not just radiology, be embedded by foundation models. So you extract these key characteristics from your pathology images, from your clinical data, from even your genomics, for example. And you build this patient state vector, and commonly also referred to as digital twin, right? And from there, we can do very powerful things. So we can compare to very similar patients and see what treatment they got and how they responded, and then have a customized, personalized recommendation. If you really want to go futuristic, I think we will go to a time where AI models will reason in this abstract space of these embeddings of foundation models, where we as humans never made actually words to describe these concepts. And then it becomes really tricky because then you get maybe super accurate treatment recommendations or follow-up strategies recommended by your AI. But we as humans never made words for describing it, it will be super hard for that AI to convey the message or the meaning or the reason why the decision was made. But I think these foundation models currently, plus some reasoning, have the potential to get us there the coming decades.
It's only science fiction until it becomes real, right? So I think that this is a conversation to depend and come back to potentially in the future.
It's always good to have these things on the record, right? And most predictions are worthless, but yeah, we'll see. It's
We'll touch back in a future video here and see how things go.
yeah, that would be nice.
One quick link to a previous conversation before we enter our final topic for the conversation. We talked about data visualization, and I'm curious, do you see the same data visualization being presented to patients as it is to physicians and radiologists, right? For example, if a radiologist is looking at a segmentation of a tumor and then makes a decision on whether or not the size is increased or decreased, would the patient see the same segmentation, or would they simply see that an AI model has helped determine that there's growth in their tumor volume over time?
Yes, that's an excellent question. And it again depends on the use case. Um, but we don't show patients any of the AI volumes before a medical professional has actually approved them. And AI models can make mistakes. It happens. I think there will be a huge benefit to the way we make clinical decisions, but we don't want to show raw AI assessments to patients. Because if the AI is wrong, it might induce a lot of anxiety in patients, right? And for example, to give you an example, the selection is also not perfect. So one of the errors actually that we had was in the selection algorithm. And then from the technical expertise, you have to make decisions on which scans you run inference on, right? Which ones you send to your AI. Now, in a DICOM study, you have different reconstruction kernels, also different parts of the body that can be imaged. And we have some selection criteria that we thought, all right, these are the right ones. And if we have two of them that are eligible, we just take the last one. That makes sense because that's the last scan that should then be the right one. Now, what sometimes happens is that they scanned the thorax and they found out on that CT thorax that they missed part of the tumor, that it grew into the abdomen. And they scanned an additional part, like just some tens of slices. Both were eligible, same metadata in the DICOM format, and then we sent the latest one, which was this small extra part of the upper abdomen. Now the AI runs tumor volume, but then it's a very small tumor volume, right? And in your tumor graph, you see stable, 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 and then a drop. And it seems like the patient responded superb. Well, actually, it was just a selection mistake. And if we would have shown that to the patient, that would be completely, I think, the wrong thing to do, right? Because they would get excited that they respond very well to the treatment. Well, actually, our selection algorithm selected the wrong scan. Now, these are things we fix, and you only find these things in semi-production, just for in the test that you run. But they happen in real life. Clinical deployment is messy. You have to monitor it, and you have to account for these mistakes before it reaches the patient, or maybe even the oncologist in certain use cases.
Again, several themes here. I'm hearing the importance of stress testing, local validation, having that shadow mode or semi production status before going into deployment. And I'm sure that could take another hour
For
of
sure.
discussion here in terms of how to really go about setting that process up for success and how to leverage the insights there for real time production. And the second is possibly the strongest message of this entire conversation. First, do no harm, right? Thinking about how unintended consequences could cause significant distress to our patients and making sure that we can get ahead of that early in the process before going to real time production, but really being on top of it even after deployment.
Exactly. And especially with these additional findings, I mean, discussion is always raising, do we need radiologists? I think we need much more radiologists in the coming decade because we are able to measure so much more things. And if we're not careful, we need a bunch of more radiologists to actually evaluate some of these extra findings we can do. Um, we don't have a lot of radiologists currently, so we have to be very selective and think through what we are actually measuring and representing to our medical professionals.
And so, speaking of more findings, our last topic here actually comes back to opportunistic imaging. And so we've seen steadily rising rates of interest in AI for opportunistic imaging. And for those of us who may not be familiar with this term, we're talking about leveraging that rich imaging data featuring incidental findings to improve population health outcomes and cost effectiveness of working up these findings. And we've seen growing portfolios of solutions for targeting those use cases, like quantifying bone density, if we're thinking about screening for osteoporosis, quantifying the degree of sarcopenia, coronary artery calcifications, and visceral body fat, just to name a few, among many others. But it seems like we've had standalone solutions for each one of these use cases. We may have a single solution that quantifies coronary artery calcifications, but that same platform or same solution, it wouldn't work too well if you tried to determine the bone density, right, of that same patient on that if it's a chest CT, for example, where you're looking at both the cardiac structures of coronary vessels as well as the osseous structures in the thoracic spine, just as one example. So, in that context, would it be, I guess, feasible to develop an opportunistic imaging foundation model that does all of these things and presents this nice packet of opportunistic findings and things to work up and look at in more detail on a future study or on non imaging diagnostic tests?
Yes, I think that will happen, and specifically if people are able to develop these good 3D foundation models, it becomes super easy to build these kind of smaller AI models to detect these findings on top of those, right? So we'll see a lot of AI models that are very capable of doing these. I'm quite skeptical on whether we should implement it based on the fact that they could not be clinically actionable, right? So, what are you going to do with the findings? And if you have to communicate these findings that you find to the patient, but you have no plan of treating them or helping them, does it do harm? Does it do good? You get into ethical situations there. And we see that in screening as well, where very few screening programs are actually reducing overall mortality, only the cancer specific mortality. And the literature is not really, really conclusive about it, so it's hard to have a grounded opinion on it. But what I would like to raise is that we should be careful with not that we don't just deploy things because they're technically feasible or because we can. We have to think about what are we going to do with those findings, and aren't we not putting more pressure on the healthcare system as is by deploying these models?
This is the another fantastic lesson I hope we get extracted and almost place as a subheading for this video is let's not just do things because we can
Yeah,
and think more responsibly about the downstream impact, not just on our workflows, right, but on the patients, on those who have to work up the additional findings that may or may not be real and among other technical and operational burdens.
exactly.
Fantastic. Well, Kevin, as we conclude here, will AI be our greatest ally or our greatest threat in the next decade? I think that's a question we try to ask, and we try. I know this is one of those gray areas, but if you had to pick a side, right, what do you think? And then in that context, what should we keep our eye on in the coming months as things get a bit more exciting here with a few major conferences coming up, major developments coming up here as well?
Definitely, Ally. I'm quite optimistic also about the future, also about AI deployment. We have to have guardrails in place, but I'm very optimistic about a future where it's going to be our greatest ally. For the coming months, and especially I think RSNA is coming up, and we've touched upon it a few times, but these foundation models are the imaging foundation models, so not the LLMs, I think are going to be the hot topic. And I think we should watch also the industry at RSNA, who's really investing in these foundation models. That's one. And who is investing in seamless integration. And that's some points I may want to raise is that, for example, these DICOM segmentation objects, we cannot integrate them currently in our PACS because our PACS vendor is not supporting these DICOM segmentation objects. And then it's very hard for our radiologists to work with it and make it a seamless workflow. And it's actually crazy to think about that we are able to have an embedded DICOM viewer in our EHR, but we cannot visualize and use these AI results in our PACS because there's no interoperability, right? So those two things I think we should work on, imaging foundation models and seamless experience for a radiologist in PACS.
And then, Kevin, I have to ask, do you use AI outside of work or is it all in context of developing these cutting edge solutions for clinical practice? And if so, what's your most common or your favorite use case there outside of work?
Yes, I actually do find myself using AI in daily life more often, and it's actually slipped in without me noticing, right? So sometimes, as a real Dutchie, I'm working on my bike, and halfway you have either a flat tire or something else breaks, and I find myself more and more then in those situations pulling out my telephone and then making a picture and asking ChatGPT or another LLM for advice on how to solve this ASAP. And actually, they're quite good. In these cases, also with helping with cooking, with new recipes, or even with daily advice. Also, I find myself actually talking a lot more to these chatbots just to get a brainstorm running in my own head about whether idea could be feasible for a grant proposal or for implementation. So yeah, it's been actually a big part of my daily life nowadays.
I think there's a parallel there for radiology and for clinical work in general, in that you use it when you need it. When there's a serious question that comes up or a chance to augment your decision making and problem solving skills. So I think it's very appropriate to end there on that call to action, which is, I think, a similar theme as usual: collaboration, making sure that we're working together to enable these smart processes, and again, being ready for our systems to accommodate some of the more cutting edge applications as they quickly change and present new opportunities here.
Yes, fully agree, Ali.
Well, Kevin, thank you so much. It's been an absolute pleasure. There's always so much to talk about, but I'm really happy that we were able to briefly touch on so many topics and really informed by some of the cutting edge work that you and your group have been performing and leading the field, honestly, in terms of translational AI and operational work. So thank you for sharing those experiences with us here.
Thanks for having me and enjoyed this conversation.
AI raises some tough questions, but we'll keep asking them. I'm Ali Tejani, and until next time on the AJR AI video series. And to those of you out there joining us for this special series, thank you for watching and listening. We want to hear more about how you're using AI and challenges that you may be facing in practice. Join us for future conversations and visit the AJR website, where you can access other articles, videos, podcasts, and more exciting content.